The question is not whether we need clean energy sources, but rather how to make a transition to cheap and reliable energy sources in the fastest possible way.
In solar energy research, computer simulations actually are a very valuable tool because they provide insight into complex physical processes in energy materials.
Higher resolution generally really improves our results because with higher resolution in space and time in our models we can better resolve the natural chaos of our real-world systems. And in EoCoE, what we try to do is we try to reduce the number of core hours we have to invest in the simulations by improving our models, which will also then reduce the power consumption of these computers to perform the simulations.
Several application codes in the energy field have not been designed for high-performance computing architectures, and they cannot exploit the computational power of these modern architectures.
The main goal of EoCoE is to create a platform, a hub, where HPC experts and the energy community can meet. And the objective of this gathering is to enhance and sharpen the performance of HPC tools dedicated to energy.
EoCoE is funding us to study these really exciting new type of solar cells called perovskite solar cells. They're much cheaper to make than silicon and they require much less energy to make than silicon. However, they don't last very long and they contain lead. So we're trying to use modeling of how the atoms behave to understand how to find new materials which don't suffer from these problems.
In the material science field, we have vectorized the molecular dynamics code called metal walls, and this allowed us to simulate supercapacitors very efficiently. In particular, we have had a gain by a factor of 5 on parallel computing architectures, and this allowed us to simulate much larger systems and to get much better insights on the physics.
On one side, we had the collaboration with the scientists within EoCoE. We have also collaborated with both big companies, and we simulate the flow over a wind farm. And on the other hand, we have also collaborated with a small and medium enterprise that is developing a new kind of wind turbine.
So we definitely made progresses. A team of domain scientists are now in contact with HPC experts and have started joint effort on a collaborative basis. The next challenge is now to adapt these scientific applications to the coming new architectures while keeping their maintainability in time. And as we speak, these new architectures are not completely known, and that's the challenge.
EoCoE has facilitated collaboration between different areas, which is very valuable. Now, to become a relevant platform, EoCoE needs to attract more HPC and energy domain experts. We need to elicit new talents and increase our collaboration of users.
EoCoE is at the crossroad of the simulation and energy transition. We have been successful in bringing together the best people in both communities, and therefore we are confident we will be able to contribute to the energy transition and foster the energy transition in Europe.